Welcome, everybody. Thank you for taking the time to join me today. My name is Sean Babson. I'm going to be talking about large-scale propagation and organic production methodologies. A little bit about myself. I have a bachelor's degree in horticultural science. I've been in this industry, specifically marijuana cultivation, for the past 4 years. Past 2 years of that, I've been specializing in large-scale operations. When I say large-scale, I mean over 20 acres, over 20,000 plants in a cycle. So today I'm going to just be touching on a few topics. Anybody feel free to raise your hand if there's any questions along the way. Due to this is a large-scale propagation thing, I'm not going to tell you guys humidity and temperature. You should know all of that stuff. So just to kind of start it all off, I'm just going to be talking about some issues and some things that I've just found through trial and error as far as scalability of propagation. So area available and the amount of plants that you need. This is something that you greatly need to consider when you're looking into propagation. Do you need 200 plants or 20,000 plants? And the reason that you need to figure this out, because it's all about timing when it comes to propagation. When do you need said plants ready? On a larger scale, for example, planting 20,000 plants over 30 acres, if it takes you more than a week to plant 10,000 plants, you're 4 weeks in by the time you're done planting, your first clones are extremely overgrown. So timing is a big issue, really understanding the logistics of your farm and what the intended use is of that. One of the other things is your environment. So I see, personally, I've done this. You set up an operation, you think, I need a greenhouse for production, I need a processing building. You're here in Colorado, you get these buildings licenses for said things. Well, the next thing you know, a greenhouse is no climate to clone in. You can't grow into your processing building because it's not licensed to hold plants. And you find yourselves in a situation where you're pulling light depth fabric or creating these microclimates inside your greenhouse to maintain clone stock for your farm. So environmental is a big issue to take care of before you go into the operation. The last thing you want to do is say, I'm going to clone in my greenhouse, and then find out that greenhouses have 15 to 20 degree fluctuations between day and night. They're not an indoor controlled environment. So that's one of the big issues rolling into that. The second thing is methods of cultivation. So what is your intended use for these clones? Is it hydroponic media? Are you going to be running NFT, deep water culture systems, hydrogen, rock wool? It's all very dependent. Your propagation is of what the end use is. I would usually not recommend somebody who's going to go large scale into a soil base use an aero cloner. One of the reasons is that there is no abrasion to the root zone once the clone is rooted in an aero cloner. So when you transplant that into its container, you end up with what is called transplant shock because the roots have never felt abrasion. They have to learn how to push through that soil. So using things like a cubed media or a soilless media to clone in does have its advantages to a hydroponic or aeroponic media going into a soil base. Also with that, you need to kind of rethink a little bit about how you propagate. So when you go onto a commercial scale, you need to decide to yourself, are you going to be able to afford to build a 10,000 square foot facility just to house mothers? Or are you going to build a 1,000 square foot room and then just house a couple to keep genetic backstock and clone off of your vegetative plants before you move them into flower? So once again, that goes back to logistics and the end use. Something that we found in large-scale propagation is that your traditional, I'm going to grow my mom this big and top it so many times, really wasn't the best way for us to go. To hit 25,000 plants in a week with 500 moms, we found the best way to go was to actually house our mothers in 4.5-inch containers. So we would clone future mother stock, put it in a 4.5-inch container, give it about 2 or 3 weeks, and it gets about 3 or 4 nodes on it. You can go in, you can take apical cuts, which is your first cut holding that apical node, and then you can go in and actually do secondary cuts and take a cut underneath that node from node to node, just like you normally would at a 45-degree angle. So that gives you 2 clones per plant. Well, you can actually come back the next week and probably take another 2 to 3 clones per plant. So by timing that out, getting 2 to 3 clones per plant, we took, for 20,000 plants originally, you take 5,000 clones, put them in 4.5-inch containers, and over the course of 4 weeks, it gives me 20,000 plants. So once again, it's all about logistics and understanding the end use of your plants. One of the other things is when it comes to the area available and methods of cultivation is size available. A lot of people turn to products like the Aero Cloner because they give you such quick rooting times. And it's true, I can hit roots in 7 to 10 days in an Aero Cloner versus 14 days in a tray style situation. But with that, 120 site Aero Cloner would take up one entire shelf on one of my racks. I can fit 7 72 site trays in that same square foot as a 128 site Easy Cloner. So do you want 128 clones in 10 days, or do you want 500 clones in a matter of 2 weeks? So that all plays back to, what your end use are and your space available. Workforce and scalability. This is, like I said before, preconceived notions of how things are done on propagating in a smaller scale in your house, even in an indoor environment. Preconceived notions of how you did things need to go out the window. It's not a one-man band. One person is not going to go out there and take the cut and then go inside and then soak it and then put it in its cube and then put it in a tray. That's just not logical. Because in order to take 25,000 clones, you're either going to have 25 people doing that on a regular basis, or you're not going to hit your numbers. So with workforce, you're streamlining process. I mean, it's just like any other manufacturer or factory that's creating a widget or whatever you want to call it. And, one of the ways that we hit our numbers is by the delegation of process. So we would take a team of 6 people. 2 people would be cutters. So they would walk out there and they would cut the clones and they would fill trays. And that's what the picture that you can see up here on the right-hand side is. The cutters would go out and literally fill these trays with hundreds and hundreds of cuttings. So then they would take these back into the propagation area where you would have a sticker. The sticker's job is to just take that clone and stick it in the soil or stick it in whatever media we're going to do. Then they put it on the rack, and then that's the propagation manager's problem. It's all about the delegation of power. So, you need to understand what each process or what's involved in each step of the process to do your specific style of propagation, whether you're using an endoburic acid or using a liquid dip and grow or whatever your cloning style is or your methodologies are. You need to make sure that is scalable and doable over a large scale. Something like a aeroponics system was something that we had strived for originally, but in a greenhouse setting with constant temperature fluctuations, you're spending way too much time changing reservoirs, worrying about pH and all of that, whereas when we go to the cubes, it's pretty much if the media is saturated to the point that it needs to be, we can fill these trays and then we don't open them until it's time to plant them. Anybody have any questions so far? So yes, I specialize, with my background, I specialize in soil science, specifically no-till systems, and a lot of indoor facilities and greenhouses. When I say with organic propagation, there's a million ways. We've seen great success using salicylic acid and aloe as a rooting agent, and we've also seen great success using like a willow powder. There's tons of different options to go out there and propagate with. Seen super great responses with IBA and, NH3 and different acids that aren't organic as well. We've seen that it's a lot cheaper to go organic. You can go and buy a 5-pound bag of food-grade aloe for virtually nothing, and then, salicylic acid is readily common available. There's 50 different brands on the market. You can pick your poison, and then that's pretty much it. So we clone with that media in mind. Now, that's what I was going to step into next, is some mothers. It's just a 3,000 square foot greenhouse of moms. So this is something that I can talk to you about. So when we were cloning on a large scale, especially with organic production, something that we were finding was cost per plant. One of the biggest, weirdest things coming into this industry is nobody keeps track of metric. I couldn't tell you how many business owners that have no idea what a price per pound is, what their price per plant is. They don't keep track of these things. So keeping track of metric and understanding your cost per plant can greatly dictate the way that you clone as well. And this goes back to, organic methodologies are actually the cheaper options. A lot of people think organics are more expensive. So one of the big issues we saw in an organic situation is that certain products like root riot actually have a polymer in them that degrade due to like an organic environment, and then that can fluctuate pH. So we started to step away from that. I've ran root riot, rock wools, jiffy pucks, you name it, we've cloned in it. And what I've actually seen the best results with is Soilless Media. I'm here on behalf of a company called Miller Soil. I don't work for them. I'm a farmer, but I've worked with him in the past. He supplies soil for me. And one of the things that we got from him was called CDM Pro. It's really similar to a Pro Mix. And we found our best results by taking a Pro Mix Soilless Media, saturating it to about 60% moisture content. That's where you can squeeze the soil and you get a little bit of water dribbling out the bottom. So we would mix the soil to about 60% moisture content, and then we would pack those into a 72-site insert tray like you would put rock wool cubes in. Now, I know you're thinking mixing soil. Well, it still takes a lot of time, and you're still going to have to pay somebody to fill that tray with root riot or rapid rooter plugs or oasis cubes or whatever it is you're doing. You're still going to have to fill your tray with media. We found it was a lot easier to have the guys fill trays, these 72-site inserts, with Pro Mix. Now, we would fill these trays up, we would clone into them, and we would actually run tape around the seal of the dome just to keep bugs and really to keep the employees from lifting the lids. We don't spray them. We don't add humidity or anything like that to the leaves. I'm not worried about keeping them wet. On this scale, if the moisture content's where you need it to be, in the the media saturated, there's enough moisture in that dome. It'll stay wet for 14 days, I promise. Then one of the big things that led us to using this CDM Pro style cloning trays is the cost per plant. So I believe it's $30 for a bag of 100 plugs of root riot or whatever the brands are out there right now. At that rate, you're looking at about, I think it's right around 40 cents per plug. So every clone that you take, whether it roots or not, so you're taking 20,000 clones and you're paying 40 cents 20,000 times. These numbers add up very quickly. And then, on that large of a scale, you can expect a 20% dieback rate. So now you lost 20% of that. You're losing substantial amounts of money on these little cubes. If you can take a soilless media like this, and let's say it costs $40 per 6 cubic feet, which is pretty standard off-the-shelf pricing for something like that, you can get your cost down in a 72-site insert tray to 1 cent a plug, 2 cents a plug. And, that's just the plug. That's not your cost of labor, your nutrients, and whatever that you want to do with it. But that's what really steered us this direction. So we started cloning, figured out different methodologies. This is where we ended up. It was the cheapest option for us. And then from here, we go into containers, into the fields. I'm going to kind of jump into a little bit more of organic talk. So no, I'm kind of all over the place. I apologize. I'm a farmer, not a public speaker. I actively manage a 30-acre recreational marijuana farm down in Pueblo, Colorado. We successfully just harvested 22,000 plants last Friday. So I've been very, very busy myself. I didn't have much time to put this together. So yeah, any questions about propagation before I kind of roll right into some soil biology? Yes, sir. Not so much. We have very strict integrated pest management programs, and then we found that by keeping the moisture content, getting the moisture content where we want in the soil, means that we don't actually have to spray the leaves of these clones. So the humidity will stay up in the domes without actually having wet leaves, so we don't run into PM issues. I do not have my guy spray and lift the dome and add water or anything like that. Because if you're running into issues where your clones are drying out, they either need to be rooted or your environment's not right. It's as simple as that. Soilless media, yes, ma'am. When I say soilless media, I'm usually referring to like the ProMix style CDM project, yes, ma'am. Yes, sir. So in the commercial operations that you see here, we were just using aloe and silica. So that it go back a couple of slides and you saw all of those cuts sitting in black trays. That water was actually aloe and silica. So we would mix up the trays. We'd have them take the cuttings out in the greenhouse and then just lay these immediately in your rooting media, whether it's aloe and silica or whatever you so choose to use. Anybody else? Yes, sir. A light source? For clones, okay, it's a good question. So typically we use high output T5s. I really like the 4 bulbs. 8 bulbs are a little much, especially for just propagation. And what we usually find is I unscrew the bulbs and I run 2 for when we first clone them. And then once, I'll wait about 10 days, 12 days, they'll start to throw roots and I'll screw the other 2 bulbs in. Light intensity is extremely minimal for propagation. I've heard it said that if you have too much light intensity, your plant will focus on photosynthesizing and not root development. So putting too much light on a clone can actually hinder root growth. All right, so relation between biology and plant health. One of my favorite things to tell people, this sounds kind of goofy, healthy plants don't get sick. Healthy people don't get sick. If you're eating right and you're healthy and you're active, your immune system will take care of you. One of the issues that we face in this industry using synthetic nutrients, fertilizers, and creating these synthetic environments is that we bypass natural processes. And you can think of it, synthetic nutrients like an IV. You're feeding it straight into the plant root zone. You're bypassing its need to eat, its need to digest, its need to fend for itself. And the reason that I bring this up is that we've seen, I specialize in open field cultivation on a large scale, whether it be in beds, straight into a field, or container production. And what we see is that when you go into these larger scales and you've bypassed natural processes through cloning and through, holding them and hardening them off into going into the fields, that when you transplant them, they cannot fend for themselves because you've bypassed natural processes. Plants secrete what are called exudates. So a plant will secrete an exudate, it's like a sugar. That attracts bacteria and fungi. The bacteria and fungi will eat that sugar, and they'll also eat whatever other organic matter is around that root zone. They turn that into an inorganic matter that they hold inside their body. Then protozoa, nematodes, amobia, bigger things move in. They eat the bacteria and fungi, and then when they poop them out, it's in an inorganic form that's readily available to the plant. Last time I checked, there's only 1 nitrogen on the periodic table. So it doesn't matter if you're using synthetic nutrients or you're using an organic nutrient. When it gets to the root zone, it's the same exact thing. In a biological, organic, scalable operation, this is really important to us because phosphorus, for example, is only available within 1 inch of the soil profile. Doesn't move. So in a container, it's pretty easy because you can keep your soil mix and load it up with all your nutrients. Go out and plant on 6-foot centers over 20 acres and let's see how much phosphorus your plant can get. It's very difficult, especially drip, when you're irrigating over that much space. Using even water-soluble nutrients, you run a couple of acres of drip tape, you're going to get some bioslime buildup. You're going to get clogging. So we found that our best option was to really rely on the biology in the soil. Things like I said, phosphorus doesn't move through the soil profile. So we get fungi, bacteria, and these other microbes to go out there and find the phosphorus for us. And then that has worked all the way back into that root zone through the soil food web. How many people here are familiar with the soil food web? Come on. Right on. There's a couple of you. So, when I say the soil food web, I mean there's this food chain that exists within the root zone. And like I said, it all starts off with the simple sugars that the plant excretes, and then fungi and bacteria eat them, and then protozoa and nematodes and things eat them, and then arthropods and soil shredders will come in and eat them. So it's this living, breathing process, natural system of checks and balances that exist in your root zone. So biology and plant health are very important. When you bypass natural processes, like I said, your plant can't fend for itself. You're putting it in a bubble, is a good way to put it. It doesn't ever have to, it never gets a flu, it never gets the cold, so when something acts upon it, it just dies. A healthy plant can handle a spider mite attack. If it couldn't, there would not be any plants in existence and only spider mites. I mean, these plants have been around for thousands, millions of years without us. We give ourselves too much credit. These things have been growing for a long time without us, with no issues. A great man once said, nobody ever fertilized the forest. And that's the methodology that we use in these systems. So, and that, like I was saying, problems with synthetic cultivation. So when you use a sterile environment and you create a sterile environment, you have no good bacteria and you have no bad bacteria. If you've heard people say the problem with using like antibacterial hand soap, it can be more harmful than it is good because you're stripping all bacteria, the good and bad. Unfortunately, bad always reproduces quicker than the good. So when you start in a sterile environment, something like a rock wool, and then things get unfavorable, which they do. I mean, it's life. Things happen. Temperatures fluctuate. Lights go out. Pests get in. And when you're in a synthetic environment, though, you can kind of see over here with the algae growth and mold. That's because that was a sterile environment. There was no beneficial bacteria or beneficial microlife there to outcompete the bad. On the right-hand side, you see spider mite stippling. Everybody in here is probably familiar with spider mites. Like I said, if your plant is healthy, you can beat the infestation. Spider mites are not the end of the world. I come from horticulture. I come from agriculture. I've grown acres of cucumbers and tomatoes. We had spider mites there. We didn't spray nasty chemicals on them. We were an organic operation. So, plants can fend for themselves if you create the proper environment. So, encouraging the proper soil biology is extremely important. And not only that, but understanding what is soil biology. If you're really interested in going into organic production, I highly recommend you learning about the soil food web, you learning the periodic table, learning the basic requirements for a plant, and then take it a step further, and then you need to learn the good from the bad, the good bugs from the bad bugs, the good fungi from the bad fungi. And that's why I kind of put these pictures up here. A lot of people see molds and they freak out. This is very exciting for somebody like myself in an indoor environment. This is actually fungal hypha. So these are what I was talking earlier, fungi actively feeding on organic matter. That hypha will be acted upon by other organisms, then be released as an inorganic form to the root zone. So I'm basically feeding my plants synthetically, but through natural processes, because like I said, it's only absorbed through the root zone one way. It's all inorganic eventually. So on right-hand side over here is a top. I just reached down and grabbed some topsoil from one of our 5-gallon containers we house a mom in. We mulch all of our containers to help with soil or moisture retention in the soil, and it gives biology a place to hide. We do introduce worm cocoons into 4.5-inch containers. That gives them time to sprout about the time we put them either into the field or their final container. So what you see over here on the right-hand side are worm castings, neem and caranja, which is neem cake is very similar to the azoractin and foliar sprays that you guys are familiar with, preventing against pests. You can actually purchase it as a nitrogen-based fertilizer, top dress with it. It is great defense against thrips, fungus gnats, root aphids, and other soil-dwelling insects that can be an issue. But good biology can feed on it, turned it into a food source, and now I have my food source for vegetative growth. I don't have to add anything. That's slowly being released at like 102. I'm getting the exact growth that I want. On the right-hand side, you see a 4.5-inch container. You can see by the little stem that this is a clone that we've just transplanted. So typically after we transplant the clone, on the left-hand side, that is covered with what's called Bokashi compost. Now, Bokashi is it's an anaerobic fermentation method that is used predominantly in Asia. It's very popular. One of the reasons that I have adapted it is because over 5,000-foot elevation, things don't decompose like they're supposed to. It's a lot harder to create compost. It's a lot harder to source quality compost. Where I'm located in Pueblo, it's so high, dry, and windy, you couldn't get a compost pile to stay where you put it. So we, have done a lot of research. The Bokashi is usually just like a wheat bran or sawdust, usually inoculated with a lactobacillus, lactobacillus, photosynthetic bacteria, and a couple other things. So it's all beneficial biology. Basically, we top dress these 4.5-inch containers to get a jump start on biology, and then introducing that into the field, we are introducing said biology out there as well. So what you see here is some natural pests that just existed in the soil. These were not introduced. When you use everything's about the quality of your inputs. If you go in it haphazardly, you're going to have haphazard results. Using quality soil, quality organic inoculates, compost, worm castings, things like that is extremely vital. What you can see here on the right-hand side are orbital mites. These are soil shredders. So I use living mulches. I don't know if any of you guys are familiar with it. You can actually grow plants on the surface of your containers and then mow them down like you do with your lawn. And then the worms that you have in your bed and the arthropods in your bed will eat that and turn it into a food source. So these are orbital mites on the right-hand side that are actively eating organic matter, breaking it down. On the left-hand side, we have those are Hypelius milis. Those are a beneficial soil mite. You can actually purchase those from a great number of vendors. They actively hunt fungus gnats. They've been known to attack root aphids and also thrip eggs that are in the soil. They eat each other. They eat other mites. They eat decomposing organic matter. They eat the fungal hypha. They eat everything. And then things eat them. So it goes back to, it's a soil food web. Now, this is, natural pest mitigation. So fungus gnats are extremely common in organic environments because fungus gnats eat fungus, which forms on decaying organic matter, which just so happens to be what we feed our plants. So fungus gnats are very problematic and common. Using things and encouraging your soil to house things like Hypelius milis or orbital mites are highly beneficial. Running things like harmful pesticides. Here in Colorado, we have strict guidelines on what we can and cannot use for marijuana production. It's a great thing. Work very hard and diligently on the list of allowable and unallowable pesticides. Now, to that, a lot of people here are probably not from Colorado, and they use things that aren't the best in the world. Now, when you use things like Eagle 20, these miticides and these malabutanol and these harmful chemicals, when you foliar spray your plant, it's dripping in the soil and it's killing these guys. So guess what? You sterilized your media, bad guys reproduce faster than good guys, and you're running into issues. Natural predators, same thing. If you guys are using harmful chemicals, you're going to, not only are you going to kill a food source for the beneficials, but you're also going to kill the beneficials. In commercial agriculture, we have a term called threshold. A threshold is the amount of insects a plant can hold before you start to lose value on that crop. So when you have 30 acres of cucumbers, you don't run and spray at the first sign of spider mites or the first sign of aphids, because they're there. It's the way of the world. You're never going to sterilize that much space. But relying on natural processes, so over here you can see they're Predatorial mite Sachets. They actively hunt down. These are for, we had a russet mite infestation. If any of you guys are familiar with russet mites, that's like one of the worst things that you could possibly have. But we beat it back through heat treatment and biological pest control. So we got predator mites over here. And then I just had to throw this pic up there. Walking by a greenhouse, saw a praying mantis snatch a grasshopper out of the air and eat it in half. So that's what this picture is over there. And these praying mantis, we did not introduce into our fields. They came there. We didn't release pirate bugs into our fields. They came there. Assassin beetles came there. And it's because we created an organic environment and there was food source. If we would have sprayed at the first sign of aphids, these guys would have never showed up, because you would never have the things that eat the aphids and the things that eat those, and the praying mantis eat them. So if you go scorched earth, completely sterile environment, you'll never actually encourage these beneficials to work and come in. So in large-scale production, it's way more a game of give and pull. How much is an acceptable level before you must treat? And, ultimately, we all hope to improve soil health. So my methodologies, I really pride myself on being scalable in any situation. So you can see up here, one is a field that we grow in where we've planted a cover crop. One is a no-till container. So we set up a facility where we actually run one 150-gallon container per 1,000-watt light, and then run about 4 plants per container, and then just replant into that container every single cycle. It can be done. You're not going to yield 3 pounds per light consecutively like you do in a synthetic environment, but once you have it dialed in, you can safely hit 2.5 higher quality, without having to use the harmful chemicals. So that was kind of my rant and rave. Let's do some Q&A. So anybody have any questions? Sir in the back. Oh, I'm sorry, sir. There is no price difference. Right now in Colorado, there's such a saturation of the market, there's really not much of a price difference between indoor and outdoor. And now we've got a third category, indoor, outdoor, and field products, because I'm growing straight in the ground. I'm producing product for what most people, I can sell product for what most people produce it for. Organics Organics isn't a black and white term. There's a lot of gray area in there. It's a relative term. To what degree of organics? I myself may be a little on the extreme end. When you look at organic production in the food world, they say absolutely nothing about fertilizer. Organic production in the food industry is all about pesticide use. So you can be a 100% certified organic, greenhouse selling tomatoes to Whole Foods and using synthetic salts the whole time, because they don't regulate that. Now, in the cannabis industry, we hold organics to a whole other standard. To most people in the organic industry, in the cannabis industry, organics means no pesticides, no synthetic salts. You know, really, people like myself, we don't like to use any bottled nutrients. We try to keep everything as sourced as possible. Building things like nutrient blocks, you know, dandelion, nettle, thistle, comfrey, all of these things are considered weeds and can be grown, harvested, dried out, and applied as a top dress for a fertilizer. You can grow your own nutrients at your own facility. Imagine producing everything for your plant on one site and only sending out products. It's possible. Using things like chickens, as goofy as it sounds, to control grasshoppers populations. Well, guess what chickens produce? Eggs. You're going to have happy, healthy, fat employees. Then you're going to have eggshells that you can turn into a calcium concentrate by crushing up, frying on a skillet, and mixing it with apple cider vinegar. You can collect growth nodes when you're topping your plants, and you can actually ferment them with brown sugar and an EM1 similar to the Bokashi, and turn it into a vegetative fertilizer. You can do the same thing with fruits. You can take apples and, you know, papayas and mangoes and these different fruits, ferment them and create a fruiting plant or a fruiting feed. So organics is a relative term, and it's all about you as the farmer to decide where you stand on that line. Yeah, go ahead. So I typically don't add mycorrhiza fungi. Reason is the soil that I get usually has some pre-blended into it, and then I use high-quality worm castings. So I get all of my beneficial bacteria, fungi, nematodes, protozoa, all of that stuff readily comes from. And when I say worm castings, I mean castings, not vermicompost. They're two completely different things. Vermicompost is partially eaten compost from worms. Worm castings is about 98% worm poop. Difference being is worm castings are actual humus, which means that they really can't break down more than they've already been broken down. So that's, and then as far as foliar sprays, you have to be very careful, especially in Colorado's marijuana industry, because they do test for yeast, mold, mildew, things like that. So using things like a lactic acid bacteria spray that I'd love to use, that's yeast. Yeah, I mean, you know, there's things they'll trigger for count. So typically, no foliar spraying on a commercial scale. When we do foliar spray, it's all integrative pest management. So using biological controls, Bacillus thuringiensis, Bacillus subtilis, Bacillus aquafamilius, Streptomyces, Chromobacterium. There's all of these things that you can use to fight bacteria with bacteria. You can fight fungi with fungi. You can throw out a bait in springtime, a wheat brand called Nolo bait that contains a protozoa that rips out the stomach lining of grasshoppers so they don't eat your plant. And then it passes down the line. So organic production, even with pest control, can get pretty serious if you know what you're doing. Yes, ma'am. Yes, you absolutely can. Yeah, it's a little easier to do cocoons, to add cocoons, especially if you have like in our systems, we usually run mulch, which is like a barley straw or a rice hull or something like that. So it's really easy to just kind of have a guy with a 5-gallon bucket full of worm cocoons, walk around, toss them, and then, you know, eventually they'll hatch and they end up in your fields. But yeah, the living worms in a container are very common. Yes, sir. Yeah, so organics as a term is owned by, I believe, the USDA. So, yeah, I don't really care for the term organic. I like to say natural production. I own my own company called Rocky Mountain Natural Farming. We're trying to coin our own terms because, like I said, the marijuana industry holds itself to a way higher standard than our food industry, as backwards as it sounds. I mean, we take way more care and consideration for the cannabis that our 21 and up year olds use than we do on the tomatoes that our 5-year-olds eat. It's insane kind of the way the world works. But yeah, the organics, there's really no way to differentiate yourself other than high quality. I mean, I think that, me personally, I believe that in a correct organic system, it produces the best quality possible. Yes, sir. It varies. So it really does vary. We use a food grade active aloe. It's like Aloe X200. I believe it's like I'd hate for you to quote me on this, but right around a half a teaspoon per gallon. It's extremely concentrated. Typically, you take the aloe, you actually dilute it into water and make an aloe solution, and then you add that to your final solution. So I would really just say whatever your manufacturer recommendations are. Same with the silica. It's all the same stuff that you're the saponin, the plant hormones. It's all the same stuff you're going after. Usually just go with the manufacturer's recommendation. Anybody else? Oh, yes, sir. Yes, sir. Did you not hear me talk about top dressing and adding nutrients? It's called nutrient cycling. So you top dress as you feed. You use things like green manures, cover crops. Those things are broken down. Nobody ever added fertilizer to the forest. I can trust you. If you remember that, you might be getting a little up there in age. But nobody's ever fertilized the forest. Department of Forestry never sent anybody out there with a hopper to push fertilizer through the forest. We do plant trees and we do fertilize new forests, and that's because we have wiped out old ones. So there's an exception to the rule. But traditionally, nobody fertilized the Amazon. These things are growing by themselves naturally in these natural systems. And that's ultimately what I meant by that. Yes, so in an indoor environment, we've really seen, one of my favorites is barley. It's fast growing. Grasses are usually mycorrhiza fixing plants. And then it browns out fairly quickly, so you don't end up with a lot of like green matter decomposing. And then biology loves it. Google cover crop mycorrhiza mix, and there's a couple of people who specialize in making blends that you can just order. And it's usually like mung bean and barley and just different things. The more the better. Biodiversity is key. I think I'm running short on time, so if anybody else has any more questions. Thank you, guys. I appreciate it.